Hey guys, in today's video we'll be taking a look at the brand new Hysolis Apollo portable power system. This power station features a 5,300 watt-hour battery, a 3,000 watt continuous pure sine wave inverter, a 3,000 watt AC charger, and a 4,400 watt PV solar input. That's a lot of power flowing in a lot of different directions. Furthermore, this power system can be stacked up to 36 kilowatts of continuous output and 118 kilowatt hours of energy storage. The Apollo has massive potential. This video will consist of a detailed review of the Apollo, its features, its connectivity options, and a bit of testing. Then we'll have a separate video dedicated to taking it apart and seeing how it's built inside. Now, I reviewed one of Hysolis' power systems before. About 18 months ago, it was the Hysolis MPS-3K. That was a fantastic power station that delivered reliable, efficient performance through the use of a toroidal transformer. There was one thing though that disappointed many of my viewers, and that's that the power station had used an NMC instead of a lithium iron phosphate battery. Well, there's great news. The Apollo has a lithium iron phosphate battery. So let's get to the unboxing and take a look at what we got. You can't do this yourself, but it would definitely help to have a second person. And guys, this is super easy to assemble. You simply put this bracket, it clamps down the side of the power station here, and then there's just 2 thumb screws to twist in. Oh, that's cool. Look at that. All right. Okay, so taking a look at the front of the power station, we have all of our AC and DC outputs. We have a 12 volt 10 amp. It's a cigarette lighter or an accessory style port you'd typically find on an automobile. We have a 12 volt 30 amp DC output with standard Anderson connectors here. We have 2 12 volt 2 amp barrel style jack outputs here. Then we have a series of USB ports. We have an 18 watt power delivery USB-C. We have 2 quick charge 3.0 ports, and then we have a 100 watt power delivery USB-C. In the lower left hand corner here, we have 6 AC outputs. These are standard 20 amp US style receptacles, and that is type 5-20R. On the lower right here, we have our AC output. This is a 25 amp receptacle. It's a standard RV type plug, and it is type TT-30R. If you have one of these power stations, you'll probably plug most of your devices into these standard receptacles on the left. However, if you have multiples and you're doing a stacked configuration or split phase, or you're going to wire this to a permanent like a breaker box, you'd probably use the AC output over here. Not probably, you definitely will. Towards the bottom here, we have our air intake for cooling the unit, and the cover for this is removable, and inside you'll find a filter. So if you use this on a routine basis, you'll just want to make sure this remains clean. Last but not least, on the upper right hand corner, we have our display. Tap it once to light it up. And this is also a removable display, so you can simply pull it out of the cradle there, and you can mount this somewhere else permanently if you would like. You can place it back in the cradle to charge as needed. There is a power switch here on the left hand side, and there's a USB-C port you can use for charging outside of the cradle. This communicates back to the power station with Bluetooth, so you do need to keep it within a Bluetooth receptive range, and we'll go over the display in more detail later. On the rear of the device, starting with the top, we have our AC input. This is 120 volts at 30 amps. We have a reset push switch for the inverter. We have an AC input reset switch. This looks like it might be actually a circuit breaker. We have 2 communications ports if you're going to connect multiple of these together, or additional batteries. On the top right, we have a DC input. This is 12 or 24 volts, maximum of 10 amps. We have the grate for our air circulation here, so this is going to be the exhaust. The fans are blowing outward towards the back. We have our battery connections here. This is going to be if you're daisy chaining multiple of these power stations together or connecting external batteries, you can do that here. We have the battery switch, which is a software switch going to the BMS, and this will be off for shipment or off if you're going to be storing this for a long period of time. Otherwise, the manufacturer recommends you simply leave this enabled. And there's a neat little transparent door here to prevent accidentally pressing the battery switch. On the right here, we have the solar input. These are standard MC4 connectors. And then lastly, in the lower right here, we have a connection which will go to an optional grounding rod if you choose to ground this to an earth or other type of ground. Also located in the lower right of the back of the unit, we have a series of LEDs for the BMS status, the run, alarm, and state of charge indicator. You probably won't look at these too often, as that information is more easily obtained from the front display and in more detail. On the screen here, we have 4 main options of home, settings, information, and alerts. On the home screen, we can see an overview of the amount of power and which direction it's coming from and where it's going. We have the PV charging power, the AC charging power, and the DC or car charging power. On the right-hand side here, we have the AC output or the inverter load with an on-off switch, and we have the DC output with an on-off switch. Now, one thing I noted with these switches is that you really want to tap in this little square here below the toggle switch. For some reason, the toggle switch is very close to this informational button here, and it's difficult to click. So instead of trying to drag that little toggle button there, if you simply click in the white space, we can see our inverter output switch is on. Taking a look at the settings here, we have 3 operating modes. We have UPS or uninterruptible power supply. This mode will prioritize power from the AC input, and it will only use the batteries if AC input is lost. We have AC fast charge. You'll select this option if you want to charge your battery at a faster rate. Using the AC fast charge will disable the AC output, so you cannot fast charge and use the output at the same time. We also have battery first. Using this option, we'll supply the output with power from the batteries first, and it will only fall back to grid power if the batteries are depleted. Using battery first method will not charge the batteries from the AC input, it will only charge the batteries from the solar input. Also worth noting, when you select the AC fast charge option, you'll have to select a desired AC charging source current. This is selecting the amount of power that's available at that receptacle. I'd probably recommend either 5 or 10 amps unless you're on a dedicated circuit. If you're on a dedicated circuit, you'll probably select 15, 20, or 25 depending on the type of receptacle and the type of circuit. We also have energy saver mode. This mode will shut off the inverter if the connected load is 30 watts or less. We have unattended mode, and this is an interesting new feature. Unattended mode will allow the inverter to turn back on automatically once solar power is available and begins charging the battery. And then you'll also need to set the state of charge percentage for which the inverter should turn back on. So it's defaulted to 90% here. So let's say we select 50%. This will allow the solar to charge the battery up to 50% before it turns that inverter back on. If you have a larger load connected, you'll want to select a higher percentage. You wouldn't want to set this for, say, 10% if your solar does not meet the demands of both the charger and the connected loads. That's going to result in frequent cycling of your inverter, and you want to avoid that. We have our paralleling mode here. If you're going to connect multiples of these together, are you doing a single mode where it's combined 120 to increase the current? We have split phase mode, which is standard US power 120/240 volt, and we even have 3-phase mode. Language is self-explanatory. We also have settings for the date and time, the display brightness, and the sound. And then we have a reset button for the Wi-Fi, which is something I didn't even realize this had until I'm sitting here reading off the list of features. Under the information button here, we can see some very basic information about our power system. We have the hardware and software model, a history of the amount of power that's been generated. Mine is 0. I haven't connected it to anything yet. And then we have a history of alerts, things like, battery problems or just loss of power, things of that nature. All right, first up, we have our main power input cord here. And again, this is a standard 30 amp RV plug. So obnoxious. And then we have an LP28 style connector here that plugs into the power station. Now, they've made an improvement on this connector, and this is something I really like to see. So this is the connector that came with the older MPS 3K power station, and some feedback I had provided to them and noted in my original video are that these pins are not really recessed enough in here. My adult size finger can fit in here and touch them, and I can imagine, a kid's finger can probably get in there pretty easily. So I do very much like seeing on the new version that they now have the female pins instead of the male pins in the connector. And they are recessed quite a bit, such that, unless you intentionally try to stick your finger in there, you're probably not going to have a problem. That said, I would still recommend plugging this into the power station first before you plug this into your AC power source. Additionally, if you don't have a 30 amp receptacle available like that, there is also this adapter that plugs on the end here, which will put you into a standard 15 amp AC outlet. We have a fairly lengthy cable you can use to charge this from your vehicle. It's got a standard accessory port or cigarette lighter jack on the end here. And then we have a smaller 2-pin LP20 connector that goes into the power station. This also includes a grounding rod with a nice little handle here, so you can easily place this into the ground if you need some additional grounding. And with that, we also have a grounding cable. It's a nice thick cable here with a ring terminal. This ring terminal can be connected to your grounding rod or other grounding source if you've got another grounding location available. And then we have our connector here that plugs into the power station. We have a PV connection disconnect box, breaker, and cabling here. This is very, very cool to see that they provided this. Now, this power station can take up to 500 volts open circuit from your solar panels. That voltage is extremely dangerous if you were to come in contact with it. You've got your MC4 connectors here, which you can plug into your power station. You've got your MC4 connectors on the other end, which will plug into your solar panel. And then you've got a circuit breaker here with a protective cover. This is something I think anybody manufacturing these power stations should be doing. That way it's not encouraging people to build their own cables, build their own connectors, their own circuit breakers, things like that. And then lastly, we have two of these fabric-y feeling pads with Velcro here that honestly, I'm not sure what the purpose is. Perhaps this is for bundling up your cables and making them look neat, but they are kind of long. Alright, so for my initial connections here, I'm first going to make sure the battery switch is turned on. I'm then going to plug the AC input into the power station first. On the other end, I have my 15 amp adapter, and then I have an extension cord. So this is a properly rated extension cord for 15 amps going back to a 20 amp dedicated circuit. Go ahead and plug that in. All right, so we have it set in UPS working mode here, and we can see back on the home screen, it is charging from the 120 volt source at 719 watts. And if we tap the AC source here, we can see again 721 watts. This is our AC voltage, our AC current, and we're at 59.74 hertz. Should be 60 hertz, but you know, my LV6548 does not keep that perfectly set. If we wanted to charge a little bit faster, we can go to the AC fast charge. And I'm going to select 15 amps, even though this is a 20 amp circuit, because I'm on a 15 amp extension cord and the 15 amp adapter. You have to be very careful how you're picking these options here. And it's going to give me a warning just to make sure I'm selecting the correct option. Click OK. And it still says 5 amps. Let's try that again. 15? Okay. Oh, you know what? I have to go back to home, and I have to turn off the AC inverter first. Now I should be able to go back to settings, click AC fast charge, and then 15 amps, and OK. Yep, see, you have to make sure you shut that AC power off first. So now we go back to our home screen, and we see we are charging at 1,600 watts. It's holding pretty close to 15 amps. So next, let's get some solar connected and see how that works. I've got my test solar array set up here. I am running 10, I think they're seg panels, 305 watts, and they're in a series parallel configuration. I realize there are 12 panels here, however, only 10 of them are connected for this test. So first I'm going to take my disconnect switch here, and the solar panels are going to get connected in the top leads where the warning tag is. The longer leads that come out of the bottom here will go back to your power station. So I'm making sure the breaker is in the off position, then going to connect my solar input. Remove the dust covers from the power station. I can connect my input there as well. I've now double checked all of my cabling here, so I'm ready to go ahead and flip the circuit breaker on. So taking a look at the display here, you can see we're taking in 730 watts from those panels. Now that's not the best from that number of panels. It's actually a fairly cloudy day today. But the great thing is you can combine that with the AC input. Now we're taking in 1600 from the grid and 680 from the solar. So you can see how easily you can stack this. Again, you can stack this up to 4,400 watts if you have a solar array big enough. This particular array would definitely benefit from a higher working MPPT voltage. However, it's configured for my LV6548 inverters, and I simply pulled it off for testing this power station. When I'm ready to disconnect the solar panels, I'll make sure the circuit breaker is in the off position. It is disengaged. You do not want to disconnect these cables under load. The high DC voltage will result in arcing as soon as you remove them, so it is important to make sure your circuit breaker is shut off first. Before removing these connections, you'll want to pick up one of these MC4 disconnect tools. They really should include this with the kit, and I'm actually going to make that recommendation that they do include this with the kit, because otherwise if you try to use like a pair of needle nose pliers or something similar, you'll end up biting up these connectors, and you really don't want to do that. So all you have to do is insert this connector on the top, press it down, it will squeeze in those tabs, and then you can pull your cable out. So now our power stations have multiplied, and we have 2 of them. We're going to take a look at how to connect this into a split phase for 120, 240 volt standard US power. And to do that, there is an optional cable kit you can purchase, and you will want to purchase that. That kit includes 2 of these cables with RJ45 connections at the end. And this is essentially just a standard Cat5e Ethernet cable wired straight through. This also includes a very heavy-duty cable for connecting the 2 together. This is the AC output side. And here we have the 2 30 amp RV style plugs. And this goes to a 50 amp connector here. This is a 14-50R. And that kit also includes a battery paralleling cable as well here. So we have our positive and negative battery conductors, but there are 4 pins back in there for the communications. So the first step is to make sure the inverters are off on both of them and they're around a similar state of charge. So that one's off and we're at 54%. This one's off and we are at 64%. Next, we need to switch off the battery on both units. We're going to connect our communications cables first. So COM 1 goes to COM 1 on the other unit, and COM 2 goes to COM 2 on the other unit. Next, we'll connect our battery paralleling cable, and what this is going to do is essentially put both of these batteries into parallel so they're always at the same state of charge. Since we are wiring these in a split phase system, we cannot guarantee the load on each one is going to be exactly the same. So this cable will ensure that the batteries stay at the same state of charge. And this is a big heavy duty connector, so we'll simply insert that, and the same on the other side. So now we can go ahead and turn both battery switch on, and we're done on the back of the units. On the front of the units, we're going to connect one of the RV plugs into each output. It doesn't matter which one goes where. On the left power station, we're going to go to Settings. Parallel mode, I'm going to switch this to split phase, and I'm going to select this to P1. On the right power station, I'm going to go to Settings, select split phase, and this is going to be P2. With all of that completed, I can go ahead and switch the AC output for both to on. So now I can take my voltmeter here and insert the probes to leg 1 and leg 2. And I have 242 volts, bouncing around a little bit. Leg 1 to neutral is 120 volts, and leg 2 to neutral is 120 volts. So now we have a perfect US split phase output. So now I can take this plug and I can wire it to a breaker panel, I can get adapters for it, and I don't have any 240 volt load testing to do here today, but we may do some of that here in the future. Now, I did run a capacity test on this power system. I charged it up to 100% off the AC input. I then let it sit on the charger overnight just to make sure it was fully charged and did a little bit of balancing. My test load was the 48 volt Ames battery charger, which did put approximately a 1200 watt load on the inverter, and I let it run until the power system shut down the AC output. We came in at 4,870 watt hours. This is rated for 5,376 watt hours, so that's an overall efficiency of 91%. We didn't quite hit that 94% efficiency rating that is in the user's manual. However, this did remain on once the inverter output was disconnected, so I know it is saving some reserve capacity. What that is, I don't quite know. But regardless, I think 4.8 kilowatt hours on the AC output, considering all the other losses within this unit, is fantastic. All right, we're gonna do some very quick load testing here. I have 2 of the largest 120 volt inductive loads in my home. This is a 1.8 horsepower 8-gallon air compressor and a standard 12 volt vacuum cleaner. I have some heavier inductive loads that run on 240, so like I said before, we may test those later, but for the time being, this is just going to be a very brief test to see if it can start both of these and what combination will make it shut down. And that measured approximately 1275 watts. And the vacuum cleaner measured approximately 1200 watts. Both of these combined are still below the 3000 that this is rated for, but again, with inductive loads, it's always the initial startup current. So because this is the heavier of the two, I'm going to start the vacuum cleaner and then start the air compressor and see if this shuts down. So that was actually quite interesting. It actually ran all 3 of those loads until the air compressor reached its maximum pressure and the battery symbol was blinking. So perhaps that was the the surge capacity it's rated for, but we do want to make sure this does shut down when it does reach its rated limits. So we're going to try that again here just to see what happens. All right, now I really made it mad. I had it up to approximately 4,000 watts and it did actually shut down. And you can see here we have error code E07. So now I'm satisfied that the overload protection does indeed work. And after we've cleared the fault, you can see we're able to start the inverter back up again. So we're all good there. All right, so I've been using this for about a week and I have not had one single issue. Hysolis knows what they're doing and they know what the customer wants. I can see one of these being absolutely perfect for a emergency backup power outage type scenario. This has enough energy storage and inverter output capacity to supply all of your essential needs, whether that be a refrigerator, a freezer, emergency lighting, cooking needs, air conditioning, heat pump, you name it, this can power it. And with the whopping 4,400 watts of solar PV input, assuming you have solar panels and you have enough sun, you could run all of your essentials pretty much indefinitely off of this in an emergency situation. Not only that, this would be perfect just to take a few appliances off grid if you want to reduce your energy consumption, your monthly bill, or just get a little bit less grid dependent. If you need more power, it's very easy to stack 2 or more of these in a split phase configuration, or a multiple 120 volt configuration to increase the output capacity, the output amperage. And if you're going to start stacking, 3 or more of these, I'd say you'd probably want to consider getting an electrician out just to make sure you're using the right gauge conductors, the right circuit breakers for overcurrent protection, the right breaker panel, all of the right wiring components to remain safe in your setup. If you're interested in learning more about these or maybe purchasing one, there will be a link down in the video description. That link combined with the discount code you'll find next to it will give you 5% off your order. And these do ship free throughout the United States, so there's no added charge there. Up next, we'll have a video dedicated to the teardown. We'll see how this is built inside, the build quality, the type of batteries that are used, and so forth. I will be doing some additional testing on the UPS feature, and specifically in terms of the transfer times and whether or not it is fast enough to support a load of computers or server equipment. If I do find it fits those needs, there will probably be a third video on that particular topic, but for that you'll want to go over to my server channel and subscribe to that channel. I will be publishing that video over on my other channel, Home Sysadmin, since it will be more specifically focused on servers rather than the actual solar and battery aspects. As always, please feel free to leave any questions or comments you may have. Hit that like button before you go, and thanks for watching.